Hello, my name is Mohit Deshpande, and in this course I will be showing you the back end to the Social Notes application. So, what we have here is a class called Social Notes, and inside of it you can see that we have a private constructor which prevents this class from being initialized. This class also has a final modifier, meaning that no other class can extend this class. And throughout my code you'll see comments like this, and you'll also see some Java.doc comments like this. And what these Java.doc comments do, if you hover over them, it displays the text right here. And these are really useful if you're working with someone else, because then they'll have an idea of what this method does and how they can use it. Alright, so right here we have a field called authority. And the backing end for this Social Notes application is a SQLite database. SQLite is a form of database very similar to SQL, but it's been scaled down so that it can fit on mobile phones. And we can create a class to handle all of these calls into the database, whether those calls be inserting new rows, deleting rows, updating rows, retrieving rows. We can also create tables, we can create indexes and such. Android has a really nice way of allowing developers to use this SQLite database without having to deal with some of the possible errors that could come up from this. It's called a content provider. And what this content provider does is it essentially acts like a wrapper for the SQL database. You'll see when we open up our content provider class, you'll see similar functions such as insert, delete, update, query. All of these calls are actually being put into the database and then being dynamically returned to us. So we need this authority for the content provider, and you'll see I'll make a note of it in the code. You can see we have this note class, which is also final and static, so that we can access it through the social notes class. And what this does is it basically holds all the database column and other things that the content provider will need. And of course, there's no initializing this class. This really wouldn't help at all anyway. We have this content URI. Now, content providers use kinds of URIs. They're similar to the HTTPS or FTP kind of file transfers. Like you can see this content we have here. And the content URI is simply the word content, the authority, which is the full name of, in most cases, the full name of your content provider, as well as a / and then a subdirectory. Alright, what we have here, these content type and content item types, they're essentially what the get type method in the content provider retrieves. Whether you're looking for a single note right here, this would return a single note. It would tell that the MIME type of this was a single note. Or we can return the content type here, meaning that the MIME type is notes, plural. Alright, moving on, we have these are the names of the columns that are going to be in the dash. We have a title column, we have a content column, we have a latitude and longitude columns. Those are pretty self-explanatory there. Alright, let's move on to the actual provider class. Now, when you first look at this might seem a bit daunting at first, but we're going to go through each line of code step by step, and I'll explain what this does. Alright, so we have some Java.doc here. You can see that our provider extends content provider, and this is mandatory. It must extend content provider in order to override these functions. Alright, you can see we have a tag, which is just the name of the class.class.getSimpleName, which would just return this social notes provider. And the tag is mainly used for logging. Any kinds of logs would show up here on logcat. It's where you would plug in your device or go on the emulator, and it would show you a list of logs, and really helpful for developers if you're trying to look through an error. And what logcat would do is it would tell you the exact lines of code where the error is happening. It's very useful. You can see we have some constants. We have the name of the database, we have the table name, we have the version, and we have the database helper, which I'll get to right down here. Moving on, we have some stuff that the content provider uses. We have a URI matcher, and like I said, content providers use URIs. And what the URI matcher does is it prevents our content provider from getting URIs from different content providers. Like, I'll get to this here. We initialize it here and we add 2 URIs. This is to retrieve all kinds of general nodes. This to retrieve a specific node. And what this does is it prevents this content provider from getting things like maybe from like an action insert from maybe the contacts application. Well, it shouldn't handle this because it wasn't made to handle this. That's why we have a URI matcher. We have the projection map here, and what it does is it basically maps out in Java code the columns that we're using. So it's just essentially just the names of the columns. It's a map of 2 strings. It's just the name of the columns and then the name of the columns again. And it's optional, but it's really recommended that you use a projection map. And we have some identifications that we'll use later on in the code to identify between a single note right here or all of the notes plural right here. And in most cases, it's going to be operations will be to a single note. Very rarely will it be to all nodes. Alright, you can see this little block here. We just have the word static and then 2 curly braces here. That is a static initialization block. And essentially what it does is it kind of acts as a constructor to this class, even though it doesn't have a constructor by default. We haven't put in one because it's not needed. But what it does is as soon as this class is loaded into the VM, all of this in this block is run. All the code in this block is executed. There are instance initialization blocks, but they're really rare, and why use an instance initialization block when you can just use a constructor? As you can see, we're not going to have a constructor in this class. If I can find the outline. You see there's no constructor in this class at all, other than in here, the database helper. Alright, now what this database helper is, it's essentially a wrapper for the raw SQLite database. We don't want to have to access the database and then deal with certain things, so we'll just use the database helper, and Android does a really good job of providing this for us. Now what we need is a context, and a context is really, you can read the Java doc here, interface to global information about an application environment. Contexts are very essential to the Android system here. Alright, you can see we have a constructor here, and it takes a context. What this does, this super, is it calls SQLite open helper with in a constructor. When you use this calls the constructor of the super class, which is SQL Open Light Helper. This is mandatory. It must be there. And the nice thing about the Eclipse IDE is that when you extend these classes and you create a constructor, this will be put in not this exact line of code, but this line of code will be put in by default, so you don't have to go through and manually add in all this. And you see that the context that's given to us, we assign it to this. Alright, in the onCreate here, you can see that it's on this method we have a database we can do, and what this execute SQL does is it allows you to execute a single SQL statement that is not a select or anything that returns data. In this case, what we're doing is using that context. We're getting the resources, and we're getting a resource string called createDB1. Now this class R is essentially a resource class. You can see here anything created in this folder will be referenced in the resources, but I'll delve into that a bit more later on. Here's the strings file that we're getting. We're getting this database creation version 1, and what this does is it creates a table if not exists. What this states is if this table already exists, let's not bother creating a duplicate of it. You can see we have an underscore ID, and it's mandatory. It has to have any table you create mandatory has to have an underscore ID that is an integer. It is the primary key, and it is automatically incremented for each row that is put in. You can see we have a title, text that's not allowed to be null, content, text that is not allowed to be null, and we have latitude and longitude, and these reals are essentially doubles or floating point values in Java. Alright. And you can see here I created a little helper function so that what you can do to start your user off is have a couple sample notes that they can open and see how the app works. Alright, this onUpgrade here. OnUpgrade is called when you change this number, database version, when you increment it, and you publish this update out, then onUpgrade is called because it detects that the database version is greater than the previous one. You can see we have an old version and a new version here. Now this code seems a little daunting at first, but let's dissect it and go through it step by step. What we do here is we call database.beginTransaction, and we begin transaction, and we use this exact idiom here. Begin transaction, a try, catch, and finally control statement. We have a try control statement, and the first step we do is, because it's an upgrade, the user might not necessarily have that table. So we're going to create that table if it doesn't already exist. We're going to get all the columns from this table using this helper function I created here. And basically what this does is using a cursor, which is an object that you would receive from a query, and then it contains a list of rows that match the query. We're getting just a single row from it, and then we're getting all the column names from that. Alright, so once we have the column names, we're going to create a temporary table by renaming our table to temp underscore the name of the table. And now what we're going to do is we're going to use a new table scheme to create this. And I just use the same table scheme as we have. And why you would upgrade would be, maybe what you can do is you can extend some of the features of this social notes application. Maybe you want to have, say, for example, a favor. You want users to be able to favorite their notes. What you can do is create a new table scheme and maybe have a favorites column that is an integer. 1 meaning it is favorited, 0 meaning it is not. In which case you would have to increment your database version, copy this scheme, and put in a favorite space integer. Alright, what we're doing here in retain all, what retain all does is we get the intersection between the old table and the new table. Any columns that were in the old table and any new columns that were added, it grabs all of the columns in the new table and it keeps all the ones that are in from the old table, and then it checks those with the ones in the new table. So say we added a favorites. What this would do is it would keep all the columns from the original database and not the new one. Alright, now that we have those columns, what we do here is, because this is a list of columns, what we're doing in this, what textutils.join does, what this does is it returns a string containing the tokens joined by the delimiter. So what this would do is it would loop through this, and for every column it would put the column name, comma, the column name, comma, the column name, comma, this being the delimiter. Alright, almost done. Now what we're going to do is, with this SQL statement, we're going to insert into the new table the columns here, and what we're going to insert into that table in the columns is we're going to take the columns from the old table, or take all the rows from the old table and put them into the new table. And now after that is done, we just delete the old temporary table and we set transaction successful. And then this finally statement runs whether an exception happens or not. So this will always run, and we end the transaction there. Alright, moving on. Let's move on to the OnCreate here. Well, all this OnCreate does, it just creates the open helper for which we would access all of these, which we would access the database and all the tables from. And of course we return true. Alright, the delete. As I said, content providers use URIs, and I'll show you that a bit later, how the URI works. The selection, you can see here, is a restriction to reply to rows, and these selection arguments are what we can put in the selection. We can put I think it's %s, and then it would replace all the % values with all the variables in the string array. You can see we grab a database here and make sure it's a writable database and not a readable database. We have a count because it makes us return an integer, and so why not just return that integer there. Now this is where the URI matcher comes in handy. What it does is it matches whatever this URI that we're given, and if it equals this first ID, notes, then it would go through and delete. It would just go through and use the superclass or the database function delete and delete the table name and with the selection and selection args. Rarely is this used. This is a much more common scenario where we need to delete just a single note. Now you can see we grab the note ID from the URI. The URI is containing of the note ID. So let's say this is note with ID 3. Then this would be, the URI would be content : / this authority / notes / 3. 3 being the ID of the note. Alright, now what we do is we delete from our database this is the underscore ID that we were talking about in the database. What this delete is the where clause, as in it would delete from this table where this equals this, or this is greater than this is less than this is not equal to this. So where underscore ID equals the ID of the note that we were given in the URI. Now what we have here is called a tertiary statement. And what this does is it evaluates this first part, and if this part is true, then the part from this question mark to the colon is executed. If this statement is false, then this part after the colon is executed. And then we pass in the selection arguments. And if the URI that we're given does not match any of these, then we throw an exception saying that we don't know what this URI is. And then this essentially follows the observer pattern, which can get kind of complex, but essentially what it does is it notifies any observer that this URI that we've been using has changed. And then we return the count of this. You can see it returns right there. Alright. For the type here, you can see we match the URI, and if we're looking for notes, we return the notes MIME type. If we need a single note, we return a single note MIME type. I'm going to skip ahead here to the update function, the update method I should say, and you can see this has a striking resemblance to the delete method, except we use db database.update instead of database.delete. Other than that, the code is almost always the same. Alright, let's go to the insert here. You can see we have a URI where we want to insert this. We also have a set of content values. And these values essentially store the column name and then the entry that you want. For example, let me go back into here. You can see we have content values here, and then you can see we have all the necessary columns and their values. Hello, hola, bonjour. And we insert that into the database. And it would return the row ID of where we inserted it at. Now, if this ID is greater than 0, that means this insertion was successful. Everything went well. In which case, we're going to create a URI, because that's mandatory for the return. What this does is, with appended ID, is it creates that URI that I was talking about. The content, colon, / this authority, / notes, / this ID. And then again it notifies that this URI has changed, and it returns that URI. And one thing to note here, this URI is referring to the original URI, not the URI right here. Alright. Last but not least, we have the query. Alright. Now, what this query does is, you can see it has a ton of arguments here. And we have this SQLite query builder, and really all that does is it just helps us to build these queries in a much more Java-style dynamic way, instead of having to deal with typing in raw SQLite queries. We can use this handy class to, you can see there's no SQL at all in here, because it's all managed by the SQLite query builder. We set this projection map here. We set the table on which we're going to be running this query on. If we're looking for multiple notes, that will give us multiple notes. If we're looking for a specific note, we have to append where the ID is equal to the ID given by the URI. And if this is unknown to us, we throw an exception. What we do is we get the writable database again. We have a cursor object this time, and this cursor object contains all the rows that match this query right here. And you can see it queries the database, the projection, selection arguments, and sort order is all taken from the parameters in this method. And then if you want, you can specify a group by and a having, but it's not necessary. What we do before returning this cursor is we set the notification URI to the one that was passed to us. And like I mentioned, this update function here is almost exactly like the delete method, except it uses update instead of delete. This course was created in collaboration with Pablo Farias, brought to you by Zenva. You can find and like us on Facebook at www.facebook.com/ZenvaDev, ZenvaDev. You can also follow us on Twitter at ZenvaTweets, ZenvaTweets. We also have great other courses on application and game development.